Now next topic is combination. Combination simple meaning is selection. So if as for example, to understand this topic, if we take three objects, suppose I am taking these three objects. From these three objects, if we want to select any two objects, these are three objects, we want to select any two. So this can be done by selecting A and B, selecting B and C, selecting A and C. So these are three possible selections. So out of given three objects, any two objects can be selected by three ways. If question is a question of arrangement, suppose these three objects, if we want to arrange from these three objects, we want to arrange any two objects, then this arrangement can be done by arrange A and B, keep A on left, B on right side, then keep B on left side, A on right side. Arrangement of two objects, linear arrangement, or we say permutations. These are permutations. Or arrange B and C, C and B, keep C on left, B on the right side, then A, C, C, A. So these are possible 6 permutations. Now look here. When we select any two objects, that means only you select group. So group of A and B is selected. And arrangement, that means this selection is related with this arrangement. Every selection is related with these two arrangements, two permutations. This selection is associated with these two permutations. In case of permutations, these are distinct permutations. In case of a selection or combination, we do not arrange, just we select. So select A and B, or if you select B first, then if you select A first, that is same thing. Selection of A and B or B and A, that is same thing. Selection of B and C or C and B, that is same thing. So here we are doing only selection, and here we are doing only an arrangement, or we are getting permutations. Now see, total number of permutations, total number of how many such permutations, these 6 we can calculate by this formula, that is out of 3 objects, selection of any 2 objects, that is 3 into 2, that is 6. And here you can see that 2 arrangement equal to 1 selection. 2 arrangement equal to 1 selection. So 6 arrangement equal to how much selections? So this number 3, it can be obtained by this way. that number of permutations, every two permutation give one combination. Two permutations equal to one combination. So 6 permutations, 3p2, 6 permutations equal to how many combinations? So total number of combinations 3p2 upon 2, 6 upon 2, that is 3. So here actually in case of permutation, when we select any two objects, select any two object and permute them, then this can be done by 2 factorial ways. Here 2 factorial ways, here 2 factorial ways. So this value is 2 factorial. So consider here factorial. So divide by factorial. Now look, I am taking example of 4 objects. Out of 4 objects, I am taking any 3 to arrange or to select. See, suppose A, B, C, D. These 4 objects are given. Out of these 4 objects, I am selecting any 2 objects, any 3 objects. Let me select 3 objects. So selection of 3 objects A, B, C, or A, C, D, A, B, D, then A, C, D, B, C, D. So A, B, C, A, B, D, A, C, D, B, C, D. No repetition of any group is allowed. Once A, B, C is obtained, so A, B, C should not be repeated in any different order. So A, B, D, this is new, A, C, D, B, C, D. If anything left, so you can see here nothing is left. I think all possible combinations are taken. These are combinations, selection or combinations. So out of 4 objects, any 3 objects can be selected by 4 ways. Now, we are coming on permutations. Now, permutation, permuting 3 objects. So, in case of permutation, what we do? First of all, we select 3 elements. Suppose I am selecting ABC. Selecting ABC, it can be permuted by A, C, B, B, A, C, B, C, A, C, A, B, C, B, A. So, when we permute any 3 objects from given 4 objects, what we do? First of all, we select any 3. After selecting, we can arrange this in different way. So this selection gives 3 factorial. This number is 3 factorial. 6 arrangements. So 1 selection equal to 3 factorial permutation. 1 selection is 3 factorial permutation. 1 selection is 3 factorial permutation. Now here we know total number of permutations is total number of permutations in this case is these 4 objects permuting any 3 objects. It can be done by 4p 3 ways. So these are 1, 2, 3, 4, 5, 6. So that is 4 into 3 into 2, 24. Such 24 arrangements can be obtained. 1 equal to 6. For this selection, again 6 more. For this selection, again 6 more. For this selection, again 6 more. So total 6 plus 6 plus 6 plus 6, 24. So 6 permutation is related with 1 combination. That means 3 factorial permutation. 3 factorial permutations is related with 1 combination. Therefore, 4p3 permutations related with how many combinations? So here it is 4p3 upon 3 factorial. 4p3 is 24 upon 6, that is 4. So these are 4. So we are getting formula for number of combinations. Say here total number of combinations of n objects taken r at a time. Total number of combinations of n objects taken r at a time is denoted and defined as notation is NCR. N objects are given and combinations of R objects. So NCR is equal to, here this is total number of combinations of 4 objects, total number of combinations of 4 objects taken 3 at a time. So this is value of 4C3. In previous example, I took 3 objects and I was selecting or arranging any 2. So this was value of 3 objects were taken and number of selection of 3 objects taken r at a time. So this was value of 3C2. This was value of 4C3. So formula is NCR. NCR is NPR upon this number is here R factorial. R factorial. So remember formula, if n objects are given, from given n objects, you want to select any r objects, then total number of such selections, to calculate the total number of selections, it is equal to total number of permutations divided by r factorial. And here why we are dividing, I explain reason. So because here r factorial equal to 1 combination. r factorial is one combination. That's why dividing by r factorial. So NP are combinations, NP are permutations equal to how much combinations? Simple, it was simple calculation. R factorial permutations, R factorial permutations equal to one combination. So NPR permutations equal to how many combinations? So NPR is divided by R factorial. Implies, say this can also be expressed as NPR equal to NCR into R factorial. Now see, from this formula, we can put here a new formula. It's another form. NCR is equal to, already we are having formula for NPR. NPR was n factorial upon n minus r factorial. NPR is n factorial upon n minus r factorial divided by r factorial. So this r factorial keep as this. So see NPR. So NPR. So here it is formula for NPR. Divide by r factorial. Divide by r factorial. So this is formula for NCR. And here this r must be more than 0. Maximum value of r is n. R can be also taken 0. Minimum value of r 0 is also allowed. So here NC0. NC0, that means if n objects are given, don't select anything. So it can be done by one way. Don't select anything. NC0 is 1. You can also calculate from this formula. Put here 0. Putting here 0, 0. So NC0 is n factorial upon n factorial into 0 factorial. So it is 1. NCN is also 1. If you could keep your n, so NCN is also 1. Then NCR. NCR is, see, before explaining this result, here I am explaining one example. Suppose question is calculate 6C4. 6C4. So say 6C4 is 6C4. It is equal to 6P4 upon 4 factorial. 6P4 upon 4 factorial. Now 6C4 is 6 into 5 into 4 into 3. Beginning from 6, take 4 steps back. 6P4. So beginning from 6, 4 steps back. 1, 2, 3, 4. Upon 4 factorial. 4 factorial is 4, 3, 2, 1. So this is 4 into 3 cancel, and here 2 into 3 is 6. So this is 15. If we calculate 6C2, 6C2, that is 6C2 is 6P2 upon 2 factorial. 6P2 upon 2 factorial. 6C2 is 6P2 upon 2 factorial. That is 6 into 5 upon 2 factorial is 2 into 1. That is 15. Suppose we want 10b, taking 7, suppose I am taking 8, 8b 5, 8c5, 8c5. So say 8c5. Here what we are doing, observe this calculation. 6c4, from 6, 4 steps back upon 4 factorial. 6c2, so from 6, take 2 steps back upon 2 factorial. So similarly, 8c5, from 8, take 5 steps back. So 1, 2, 3, 4, 5 upon 5 factorial. So 5 into 4 into 3 into 2 into 1. So calculating this, 5 into 4 is cancelled, 3 into 2 is 6. So this is 56. 8c3. So from 8, take 3 steps back. So 8 into 7 into 6. 3 steps back upon 3 factorial. That is 3 into 2 into 1. So this is 56. Now look here. You can see that 6c4 equal to 6c2. Look here. 56 equal to 56. 8c5 equal to 8c3. So now observe these results. 4 plus 2 is 6. This is what? It is difference of these two numbers. 6 minus 4. Look here. What is it? It is difference of these two numbers. This is 8 minus 5. So now from this example, I am putting one result, that NCR is NC n minus R. NCR is NC n minus R. So NCR is NC n minus R. So remember, when this lower number is less than half of this number, then calculation by this way, it becomes a short. But when this number is more than half of this number, say this is more than 4, so calculation becomes lengthy. Value is same. So remember, whenever you want 8c5, don't take 5 steps back, but calculate 8c3. If you want 100c 98, in calculating 100c 98, if you take 98 steps back, so you have to write 98 numbers, 100 into 99 into 98 into 97, 98 numbers in decreasing order. Divide by 98 factorial. If we apply this formula, or if you do by this way, so 900c 98, so from 100 to 98 step back upon 98 factorial, so it becomes too lengthy. But instead of that, what we shall do, because this number is greater, to calculate 100c 98, we will calculate 100c, take here difference of these two numbers, that is 2. So 100c 98 is 100c2. So you need to write only two numbers, 100 into 99 upon 2 into 1. So within seconds you can calculate. So NCR is NCN minus R. And look, whenever such expression is given, sum of these two numbers is always 6. Say 6C6 equal to 6C6. This is true. And 6C5 equal to 6C1. This is also true. So whenever we have NCA equal to NCB, that means NCA is equal to NCB. That means either these two numbers are equal, A equal to B, or sum of these numbers is 6. If these two numbers are not equal, then sum of these numbers is n. So A plus B is n. And that you can see here. 5 plus 3. See, these numbers are not equal. But what is their sum? 8. Sum of these two numbers is 6. Sum of these two numbers is 100. So that is important property. Then there is one more result. NCR plus NCR minus 1. NCR plus NCN minus R, or you can put here R minus 1, put here R. Smaller I have taken first, then greater. So NCR minus 1 plus NCR is equal to N plus 1 CR. NCR minus 1 plus NCR is N plus 1 CR. As for example, 11C9 plus 11C10. Look here. N is 11. N is 11. If R is 10, then R minus 1 is 9. So by this result, its value is N plus 1, that is 12. See, out of this number here, greater is taken. Which is greater in these two numbers? R. So here greater is R. If I take 40C21 plus 40C20. So applying this result, NC40C21 plus 40C20. See, upper number is same. If upper number is same and in this location lower numbers are consecutive numbers, if these are consecutive numbers, any one will be smaller, other will be greater, and here will be greater. So when upper number are same, we keep here plus 1. Lower numbers are consecutive, keep here greater. So upper number are same, we keep here one more, that is 41. These are two times consecutive. Now which is greater? 21. So put here 21. So these are examples to understand this rule. So here these are the results. Let me say 1, 2, 3, 4. This is 5, 6, 7. These are 7 results. If NC8 is equal to NC2, find value of NC2. Say here NC8 is equal to NC2. So by rule, just I explain, if NCA is equal to NCB, upper numbers are equal, lower numbers are unequal, then sum of these lower numbers is equal to n. So here n will be equal to a plus b. So n is equal to 8 plus 2. So n is 10. And putting n equal to 10 here, so NC2 is equal to 10C2. And 10C2 is 10 into 9 upon 2 into 1. From 10, 2 steps back upon 2 factorial. So this is 45. Here 2 NC3 is 2 NC3 is 11 is to 1. So ratio is given 2 NC3 upon NC3 is 11 is to 1. So remember here in notations there should not be any confusion. In this question 2 NC3 number of objects given is 2n. There is difference in these two terms 2 into NC3. So don't read this as 2 times NC3. This is 2NC3. Number of objects are 2n and 3 objects are selected. So 2NC3 upon NC3. Now 2NC3. So taking expression for 2NC3, beginning from 2n, 3 steps back. So 2n into 2n minus 1 into 2n minus 2. Beginning from 2n, 3 steps back. Upon 3 factorial. Upon 3 factorial. Divide by NC3. So beginning from n, 3 steps back and minus 1 and minus 2. 1, 2, 3. Upon 3 factorial equal to 11 is to 1. So that is, this will be cancelled. Here n will also be cancelled. Here taking it 2 common, so 2 into 2, 4 into 2n minus 1 into n minus 1 upon n minus 1 into n minus 2 equal to 11. 11 is to 1 is 11 by 1. N minus 1 cancel. So 4 into 2, 8n minus 4 equal to, multiplying this on this side, 11n minus 22. So therefore, 11 minus 8, 3n is 24 minus 8, 80. So n equal to 6. Now here, how many chords can be drawn through 21 points on a circle? So if there is a circle, on this circle there are 21 points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 like this. There are 21 points on this circle. Now, if we draw a chord through these points, then what we have to do, we have to select any 2 points from these 21 points. Suppose I am selecting this 2 and join that selection. This is a chord. For a new chord, select again a distinct pair of points. Suppose I select these 2 points, join them. It's a chord. For a new chord, suppose I select these 2, join them. This is a chord. So what is the experiment? Select any 2, join them. Select any 2, join them. So number of a selection of 2 points is equal to number of chords. So here total number of such selections of 2 points, given points are 21. So out of 21 points, every time we select 2. So total number of selection of 21 points taken 2 at a time. That is equal to number of chords. So total number of chords equal to from 21 points select any 2. Every selection is a chord. So that is equal to 21 into 10 upon 2 into 1. 2 into 5, 10. 105. 105 such line segments can be drawn. In how many ways can a team of 3 boys and 3 girls be selected from 5 boys and 4 girls? From 5 boys, we want to select 3 boys and from 4 girls, we want to select 3 girls. This is step 1, this is step 2. So step 1 can be performed by from 5 objects we want to select 3 objects. So it can be done by 5C 3 ways. Step 2, 4 girls are given. We want to select 3 girls. So from 4 girls, 3 girls can be selected by 4C 3 ways. This step by 5C 3 ways, this step by 4C 3 ways. If one action by m ways, other action by n ways, then both actions in order can be performed by m into n ways. That is 5C3 into 4C3. So here, this is step 1, this is step 2. So total number of step 1 can be performed by 5C 3 ways. Step 2 can be performed by 4C 3 ways. So both steps in order can be performed by, that means total number of required selections equal to m into n, 5C3 into 4C3. Now 5C3, now look, as I told, this lower number, value of r, it is more than half of 5. In that case, what we do? We put this in simple form, 5C3 equal to 5C2. Subtract 3 from 5. This is more than half of this number. Into, similarly here, 4C3. 4C3 is equal to, what is 4 minus 3? So put here 1. So we make in a more simple form when this value of r is more than half of n. So then in next step calculation becomes simple. 5c4 is 5 into 4 upon 2 into 1 and 4c1 is 4. nc1 is n. That is 2 into 2 4. 5 into 2 10, 10 into 4 40. So total number of required selections 40. And here remember nc1 is n. From n objects, if we want to select any one, so it can be done by n ways. Or if you apply formula from n, take one step back, so n itself upon 1 factorial. So nc1 is n. nc0 is 1. nc0 is 1. nc1 is n. ncn is also 1. nc0 is 1. ncn is 1. nc1 is n. nc0 is 1. ncn is 1. nc1 is n. Determine number of 5 card combinations out of a deck of 52 cards if there is exactly one S in each combination. That means, see, a deck bunch of cards contains 52 cards. Now in 52 cards, we can imagine, not imagine, but it is true that bunch of these 52 cards contains 4 kings, 4 S. Question about S. Determine the number of 5 card combinations out of a deck of 52 cards if there is exactly one S in each combination. Bunch of cards contains 52 cards. Now in 52 cards there are 4 S. 4 S, so 48 others. 4 cards are of S and 48 others, so total 52. Now we want to select 5 card combinations such that each combination contains 1 S. From this bunch of 52 cards, we want to select 5 cards, but condition is, in this combination of 5 cards, 1 card must be S. So for that, what we do, separating 4 S cards and 48 other cards, make 2 separate bunches of other cards and S cards. We need 1 S. So 1 S can be selected from these 4 S cards. So select 1 S from these 4. And because we want 5 cards, 1 already selected, so remaining 4 cards select from 48 others. So from this select remaining 4 cards. So first action, this is second action. Performing both actions in order, total, then number of selected cards will be 1 plus 4, 5 as per given condition. So here total number of required selections equal to, from 4 select 1, 4 S cards select 1 S, and 48 other cards select 4 cards. So if one action can be done by m ways, other action can be done by n ways, then by fundamental principle of counting, both actions in order can be performed by m into n ways. If we perform both actions, then we use here into. So this means and, selection of 1 card and selection of 4 cards. 1 and 4, then it becomes total 5. So this is equal to 4 into 48C 4. So this is answer, or it can be also evaluated by 48 into 47 into 46 into 45 upon 4 into 3 into 2 into 1. This 4 cancel. 3 into 15, 45. 2 into 23, 46. Using calculator, this can be calculated. But if this number n is much greater, then no need to show the real calculation. This can be taken as final answer. In how many ways can one select team of 11 from 17 players in which only 5 players can bowl, if each cricket team of 11 must include exactly 4 bowlers? That means, say here, there are 17 players. 17 players. Out of 17 players, only 5 players can bowl. So in these 17 players, 5 players can bowl. So 5 are bowlers. And remaining are, that is 12. 17 minus 5, 12 are others. Others means batsman, all-rounder, wicket keeper. Now we want to select team of 11 players, and condition is team must include exactly 4 bowlers. So to select a team of 11 players, we are taking the selection with this condition, that selection contains exactly 4 bowlers. So that means from these 5 bowlers, select 4 bowlers, and remaining 7. Team contains 11 players, 4 we have selected. So how many are left? 7. So 7 players we select from 4. So select 7 players from these 12 others. So this is step 1. This is step 2. Performing step 1 and step 2, total 11 players can be selected. So total number of required selections, it is equal to From 5, select 4. So that is 5C4. Into, from 12, select 7. 12C7. Step 1 by m base, step 2 by n base. Performing both steps in order, total 4 plus 7, 4 plus 7, 11 can be selected. So n into n base. So that is, now 5C4 is 5C1. 5C1 into 12C7. Now 12C7, this is more than half of 12. So to convert this in simple form, 12C7 is 12C5. 12 minus 7 is 5. 5 minus 4 is 1. So now 5C1 is 5. NC1 is n. Into 12C5, 12 into 11 into 10, 9 into 8. 5 steps back upon 5 factorial. That is, this 5 will be cancelled. 4 into 3, 12. 2 into 4, 8. So product is 9 into 4, 36. 36 into 10, 360. 360 into 11. So 3600. 360. That is 3960. So it is 3960. So total there are 3960 ways we can prepare list of. We can prepare 3960 lists. Each list contains 11 players, and in no any list ditto team, exactly same team will be repeated. At least one player will be different in every list. So without repetition of same team, we can prepare list of 11 players. How many lists? 3960 selections. Now this question. In how many ways can a student choose a program of 5 courses if 9 courses are available? 9 courses are available. 9 courses are available and the student want to choose 5 courses. And 2 specific courses are compulsory. So step 1 is, from 9 courses, first of all, these 9 courses includes 2 specific courses which are compulsory. So select these 2 courses. That is step 1. Step 1 is select 2 compulsory to specific compulsory courses. Specific courses compulsory. And these are compulsory. Two specific courses are compulsory, so no option, no choice. You have to select. There are 2 specific courses in the list of 9 courses which are compulsory, so you don't have selection. You have to select. Compulsory. No choice. So this can be done by one way. It can be done by only one way. No other ways. Choose these 2 compulsory. Now, student has to select total 5 courses. So now 2 are compulsory. So how many are left that he has to select? So 3 are left. 2 selected compulsory. So still he has to select 3 more courses. And 3 courses it should be selected from remaining 7 courses. So here 9 minus 2, remaining 7 courses. So 9 minus 2, 9 minus 2, that is 7 are remaining. From these 7 courses, now select how many courses? 2 taken, 2 already taken. So he has to select 3 courses. So this is step 2. This is step 2. So therefore, step 1, by those which are compulsory courses, 2 compulsory courses, this step also can be also expressed as, say, it can be written as, I put in more simple form, 2 compulsory courses and other 7 other courses. Total 9. These are compulsory. Choose 2 courses. Step 1. Select both. No choice. And step 2. Step 2 is from these 7 courses, select any 3 courses. So total number of selection, therefore total number of selections equal to, out of 2, select 2. So 2C2. First step by 2C2. Second step by 7C3. 7C3. Out of 7, select any 3. So first step by n ways, other step by n ways. So both steps can be done by n into n ways. So then total number of selected courses will be 5 out of 9. So that is 2C2 is 1. 7C3 is 7 into 6 into 5. 3 into 2 into 1. So this can be done by 35 years.